This mini lesson is on how to graph piecewise functions and what exactly is a piecewise function. So first of all, let's go over just a couple of the items that make something a piecewise function. They are functions that make a change at a specific point. So I'm going to draw one for you in just a second, but what you're going to notice is that they are pieces of a function. So we can use the word to help us. So most of the time we will see a piecewise function being two separate pieces of a graph. In order to be a function, it still must pass the vertical line test. And then we're going to use inequalities as our guide to help guide us to solve the inequality as well as to graph these piecewise functions. So if I'm looking at a graph, what does this crazy thing look like? Here's just one example. So you would have a closed dot for one of your functions. Then you'd have an open dot for your other function going in an opposite direction. This is still considered a function because if we remember our rule, let me grab my pointer tool here. If we remember our rule, we are allowed to only pass through our graph at one spot. So if I'm looking right here, if I drew a vertical line straight down, I'm technically only hitting in one spot. I'm hitting through the closed dot. The open dot does not count. So this still passes the vertical line test because if I were to draw a vertical line, I'm only hitting one time. If I drew a vertical line, I'm only hitting one time. So I think you guys get the idea. The part that gets confusing is when I give you those inequalities and I start asking you to solve or to evaluate the function at a given point. So let's kind of take a peek at two examples. So the first example is if I give it to you in this format and I'm asking you, what's the value of this piecewise function at 2? So let's talk about how we would solve that. When I'm looking at piecewise functions, the key to the function is by checking out the restriction over here. So what this one is telling me is that my graph is going to be the graph of 3x minus 1 only if x is less than or equal to 0. Then my second part of my piecewise function is that it's going to be the graph of x squared if when my x is greater than 0. So if I'm going to do a t-table here, maybe make one of these with me on your paper. Like I just mentioned to you, if I want to find what's the value when my x is 2, the first thing that I have to ask myself is, well, which equation am I using? So we're going to go over and check out my restrictions here. So if my x is 2 less than or equal to 0? No, I'm not going to use that top equation. Is 2 greater than 0? Yes, it is. So I'm going to plug it into this problem. So if I plug in 2 for x, 2 squared would give me 4. So let's try just a couple other numbers because a lot of times on the test and quiz, they're going to want you to be able to solve for multiple options. I'm just going to add a couple more in here. So let's start at the top with 0. So if I want you to evaluate this piecewise function when x is 0, what would you tell me is the output or the solution at that point? So let's check out 0. Is 0 greater than 0? No. So I'm not going to use this one. Is 0 less than or equal to 0? Yes, it is equal to it. So I'm going to plug it in here. So if I plug in 0, 3 times 0 is 0, and 0 minus 1 is negative 1. Let's try my next number, 1. Which of my two functions is 1 going to be a part of? Let's take a peek. Is 1 less than or equal to 0? No, I'm not going to use the first one. Is 1 greater than 0? Yes, so I'm going to plug it into the second one. 1 squared is 1. And last one, 3. 3 is not less than or equal to 0, but 3 is greater than 0. So again, I am going to be plugging into the second equation. So when I plug in 3 squared, I'm going to get 9. So we're getting some coordinates here, which is certainly one way that you are able to graph these two piecewise functions. But I also want to give you an alternate way to graph that I find easier, especially coming off of some of the pre-knowledge that we have from the last unit about how to graph. So let's kind of move forward. But this page is really, really good if I were to just say, without this table, what is the value of your function when x is 6? excuse me, that's when you would look at each one and say, does it belong in this category or this category? And then you would plug it in to the appropriate one. So now a little bit different. If I'm asking you to graph the piecewise function, let's try this one together. I'm going to let my top function be red. I'm going to put a little bit of red by it. I'm going to let my bottom function be green. And we're going to graph them. So remember, what we've learned so far this year is that f of x is a really fancy way of saying y equals. F of x just stands for function notation. So if I were to write these separately, let's do my red equation first. Instead of saying f of x, I'm just going to say y equals x minus 1. Can we graph that together real fast? So remember, that means it crosses at -1. And we're going to go, what's my slope? My slope's the number in front of my x, so that would be up 1 over 1, up 1 over 1, up 1 over 1. And we would continue on all the way up. And once you go one direction, you can go the other direction as well. Okay, so there would be my line for my red function. Now let's switch to my green function. So again, instead of saying f of x, I'm going to say y, and it's 2x plus 2. So let's all go up to 2 here, put our dot, and then from that dot, what's my slope? My slope is in front of my x, so I just added the 1 underneath, so up 2 over 1, up 2 over 1, up 2 over 1. When you get comfortable going one direction, let's go the other direction with my slope. Down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. And there would be my green graph. But here's the deal. When we're dealing with piecewise functions, it only wants a piece of that graph. It doesn't want the whole graph. So let's look here. It only wants my red graph where x is greater than or equal to 0. So let's look on my graph here. Here are my x values side to side. So it only wants the red graph when it's equal to 0 and greater than. That means it doesn't want any of this red down here. So let's take our eraser and let's remove that. So what I did was I erased the portion of my red graph that was less than 0, just like it's telling me to do right here. So I only wanted what was greater than or equal to 0 for my red graph. So here's 0, here's greater than or equal to. Now which portion of my green line do I want? I want the part where x is less than 0. That means 0 on less than. So let's erase the other portion of my green graph that I don't need. So I only need the portion that's less than 0. So I just erased the portion of my graph that was greater than 0 for my green graph. There's one last key that I need to do before I am done, one last piece of the puzzle here. For my red graph, it's x is greater than or equal to 0. We learned with inequalities that when it has that equal to sign, that's when you're going to get that closed dot right there. That's when that point is included. Do you remember what it means when it's just a less than sign? It means that 0 is not included. And to show that that point is not included, I'm going to have to make it an open circle right there. So let's all stop and do that. So now we have a piecewise function because now it passes the vertical line test. So 0 right here is definitely my segment for my graph. It's definitely my division point for my graph because at one point it's greater than or equal to 0. At the other point it is less than 0. So that is the division for your graph. Wherever the division for your graph is, one has to be open, one has to be closed, so that way the vertical line test still works at that coordinate. So treat these just like you do regular equations, just how you know how to graph regular equations, and then you're just going to erase the part of the graph that it is not referring to here. And that is how you get your two pieces of the graph. I hope that this short demo was helpful. Have a great day.